Okay guys, so we're graphing today. So today we're graphing quadratic functions in standard form. There's actually two kinds of forms. Does anybody remember what standard form is for a line? We had slope-intercept and standard. AX plus BY equals C. So standard form of a quadratic, and quadratic means that there's an x squared in the expression. So quadratic is when we have an x squared. A line is when there's just an x squared. Standard form for a quadratic looks very similar. We have y equals ax squared plus bx plus c. So that's what standard form looks like. So there's going to be a way of graphing when your line looks like this, and when in a different form, which we will learn about in a couple days. So what does a parabola look like? You kind of touched on this in Algebra 1, but we're going to draw a parabola and label some parts. So the parabola is the graph of a quadratic function. That's what it's called. It's not a line, it's a parabola. And anytime we have an x squared, your graph is going to look something like this. So write out the definition of parabola and draw an axis for me, or a set of axes. Okay, so we have multiple parts of a parabola. The very first thing is called the vertex. So just pick a point somewhere. It doesn't really matter where right now. The vertex is going to either be the highest or the lowest point of the parabola, depending on which way it opens. So your vertex is just a point. Let's label it. So vertex is a point, x comma y, whatever we can find it from the equation. Now parabola is symmetrical. So we have what is also called the line of symmetry, and it goes through the vertex. So before we even sketch a parabola, you're always going to draw the line of symmetry, which means it's the same on one side as it is on the other side. So the line of symmetry, we usually draw a dotted line. It goes through the vertex every time. The line of symmetry is always just a number. So the line of symmetry is the x value of the vertex. So let's just write x value. It's just a number, x equals some number. Okay, whatever your vertex is. That's this right here. We shorten it to LOS. So you can shorten it to LOS. You don't have to write line of symmetry every single time. Okay, so the parabola, the lowest point on this one, because I'm going to make it going up, is through the vertex, and it's basically a U shape, but it has to be symmetrical around the line of symmetry, or as symmetrical as you can make it. Okay. So my parabola is opening upwards. It's a U shape going through the vertex. The vertex is the lowest point on this one. We can also have an upside down parabola, and in that case the vertex would be the highest point. Okay. So just a note about this one. On this particular parabola, the graph opens up. Okay, so on this one, the graph opens up. That's what it says. And when the graph opens up, that means that our vertex is the lowest point, which we call a minimum value. If the graph was opening down, would we have a minimum value, or would it be a maximum value? So your minimum value is a number, and it's the y value of the vertex. So it's just y equaled a number. Okay. So we have a minimum value on this particular one because it's opening upwards. And the minimum value is always the y value of the vertex. So it's just the number that is y. You don't have to give the entire point. Okay? If it was opened upside down, we would have a maximum. And we're going to write all that down as well.
The maximum is x.
Okay, so let's talk a little bit about the vertex. The vertex is a coordinate, x comma y. In standard form, we have a formula for finding the x-coordinate of the vertex. To find the x-coordinate, we have to use the formula x equals negative b over 2a. This is your new best friend. You must know it, memorize it, love it. Okay? X-coordinate, x equals negative b over 2a. Always. So we solve that one, and we get an x value. So after I have an x value, I can find the y coordinate by just plugging it in. Okay? So after you use the formula to find the x value, you can use the x value to plug it in to the equation and solve for y. And that will give us the point of the vertex, negative b over 2a. So then another thing that we look at in parabolas is the line of symmetry. The line of symmetry is just the x-coordinate of the vertex. So it's always given as x equals a number. If I do not ask you for the vertex and I just want the line of symmetry, any ideas of how we could find it? How about negative b over 2a? That equals x, right? So the line of symmetry can also be found by x equals negative b over 2a, since it's just the x-coordinate of the vertex. So it's always going to be x equals some number. Okay, other things that we want to look at is minimum and maximum value. That is just the y-coordinate. So it's going to be y equals a number. So we just take the vertex and the x is line of symmetry, the y is the minimum or the maximum.
Minimum has so many loops in it.
Steps to graphing. Last bit of writing before we actually start doing this. Oh wait, no, just kidding. Our graphs. We have two types of parabola. They either open up or open down. Those are the only ones we're going to be looking at right now. Okay, so the graph opens up, which means it looks like this. If a is greater than 0, so that means if the x squared is positive. If our graph opens up, we always have a minimum value because we have a lowest point. Okay. Our parabola opens down, which means it's going upside down. If a is less than 0, which means the x squared is negative. When it's opening downwards, we have a highest point, so that means we have a maximum value. So you only ever have a minimum or a maximum. You can't have both, and it depends on which way your graph is flipped. Okay? So the steps to graphing. Step 1. You want to label A, B, and C. So we need to figure out what A, B, and C is, and state whether the graph opens up or down. Okay, so we're going to B and C and state whether the graph opens up or down. Alright, step 2, after you figure out if it's opening up or down, you want to find the x value of the vertex, which means you're going to use x equals negative b over 2a. Step 3, after we have the x value, we need to find the y value. So we're going to plug in the x value. And that's going to give us the y. After we find x and y of the vertex, we can find the line of symmetry, or LOS. And then after we do all of that, we get to sketch the parabola. And make sure you also draw the line of symmetry. Alright, so for the next two examples,
oh my God.
So, for examples 1 and 2, you don't have to write this. but I just wanted to have it written down so that you know what it is we're finding. We're going to, part A, identify the line of symmetry. We are going to identify the vertex, so we're going to have to find X and Y. We will sketch the parabola, and then we're also going to state if it has a minimum or a maximum. Okay, so depending on if our parabola is opening up or down, that means we have either a minimum or a maximum. Okay, so example 1. We have y equals 3x squared minus 6x plus 4. Draw a set of axes for me, and then we will do this one together. So, part 1, we want to find the vertex. We can't do anything until we have the vertex, okay? So, let's find vertex. Let's label it. Okay. Alright, so to find the vertex, we first have to find x. What is the formula for x? Perfect, negative b over 2a. So, x equals negative b. What's b? Negative 6. So we have negative 6 over 2 times a, which is 3. So a is the first term, or the first coefficient, b is the second. Okay, so over 2 times 3.
Wait, where did I miss this, like, formula?
Where does that come from? If you guys go back to the very beginning of your notes, in standard form, a is what's in front of x squared, b is what's in front of x. Okay, that's always the case. So b is in front of the x, a is in front of the x squared. That's where I get b and a. Okay?
When I hear the term standard, are you trying to...
Alright, so let's simplify this. We have negative 6, so what does that turn into? Positive 6 over... Over what? 6, which reduces to 1. So the x-coordinate is 1. How do I find the y-coordinate? Plug it back in. So we're going to take this guy and plug it into the equation to solve for y. So y equals 3 times 1 squared minus 6 times 1 plus 4. So this is when c comes into play, because it makes a difference on what y spits out. Okay? So that equals 1 squared is 1. So 3 times 1 minus 6 plus 4, which is equal to 3 minus 6 plus 4. 3 minus 6 gives me negative 3, and negative 3 plus 4 is positive 1. So what is my vertex? 1, comma, 1. The vertex is a point, so you have to have x first and then y. So let's graph the vertex right now. 1, 1. So that's right here. And then I want you to label it. Vertex 1, 1. Okay.
You have to label it like in the homework and stuff too.
On the homework, you do not have to label it unless it asks you to. In this particular case, identifying it, so right here we said vertex and we finalized that it was 1, 1 is okay. For the notes, I'm labeling it just so that you have all the parts labeled. Okay? Alright, so after the vertex, we can find the line of symmetry. So let's look at line of symmetry. That was pink. Okay, line of symmetry is which value, the x or the y?
X.
The x. So it goes through the vertex. So our line of symmetry is a dotted line straight through the vertex.
It has to be dotted?
Yeah, make it dotted because it's kind of like an invisible line. So dotted means that it's not part of the graph necessarily.
What honest use do you have for an invisible line?
It's a line of symmetry.
I'm just curious.
Okay,
When are you
label
gonna-
the line of symmetry. So line of symmetry is the x value, x equals what? What was the x value of the vertex?
1.
1. So x equals 1. So that's my line of symmetry.
Wait, so why is it X and not Y?
Because it's a vertical line.
Okay, so it
Which
can't be
means x is
horizontal?
always 1. It cannot be because we're not looking at those types of graphs yet.
Okay.
We're only looking at graphs that open up or down. So it's always going to be a vertical line through the vertex, which means that it's always x equals a number.
What is it called when it's sideways?
It's just a rotated parabola. We'll get there.
So, the line of symmetry.
Okay, so let's sketch the parabola. That was the next part. Part C was to sketch the parabola. Is my parabola opening up or down? How can I tell?
Opening up is positive.
We look at the x squared, and that coefficient is positive 3, so it's opening upwards. So try and draw a symmetrical parabola around the line of symmetry. So the line of symmetry is the middle of your parabola, and it's opening upwards.
How big would it or small? Does it have to be?
We have not talked about width of the parabolas yet, so you can just go ahead and do a sketch. Sketches, it doesn't matter for us. We will talk about the width later. But for right now, we're just concerned with is it opening up or down.
Can you make this?
Okay, so since my parabola is opening up, do I have a minimum or a maximum value? I have a minimum. The minimum is what value? Is it the x or the y coordinate?
Y.
It's the y coordinate. So the minimum is y equals what? What was the y coordinate? 1. So it's just y equals 1. That's what you can write for your minimum. Let's label it on our graph just so that you have a visual. That is a minimum. Y equals 1. And that is the graph of this equation. Okay, example 2. We have y equals negative 3/4 x squared minus 4x minus 1. So write out the equation, draw your axes, and then we will get started. So vertex is the first thing we have to find.
Negative.
Now we can't find the vertex until we know what x is. X, what's the formula? You guys should know this.
Negative b over 2a.
Good, negative b over 2a. So we have negative, what's b in this equation? Negative 4. So this is negative 4. So I want you guys to remember, the whatever b is, it's being multiplied by a negative. So if b already has a negative attached to it, you're still multiplying it by a negative. Okay? So it's kind of like taking the opposite of b, whatever it is. All over 2 times
3/4.
negative 3/4. Oh my
How
gosh,
does that work, like
a
a
fraction,
fraction?
don't freak out.
How does it work with like a fraction?
Well, with a fraction, we can do some cross-reducing before we actually multiply, right? 2 and 4 reduces. 2 goes into 2 once, and 2 goes into 4 twice. So we have on top positive 4 over
Negative 3 over 2.
negative 3 over 2. Okay, so I'm going to do a little bit of scratch work on the side. So this is the same as saying 4 divided by negative 3 over 2, right?
How can you have a fraction in a fraction?
Just watch. Just watch. Does everybody agree that this is the same as this?
Yeah.
Yeah.
Okay. Now when I am dividing by a fraction, think back all the way to elementary school. It means I'm multiplying by
The reciprocal.
the reciprocal. So this is the same as 4 times negative 2 over 3, yes?
Yeah.
Okay. So what does that give me? Negative 8 over 3. So x is equal to negative 8 over 3. We can have a fraction as part of our vertex. It is acceptable. So what do I do next?
Plug it back in.
Plug it back in. So y equals -3/4 times -8/3 squared, minus 4 times -8/3 minus 1. Minus 4. I started writing a plus. Okay. Okay, let's simplify. This is -3/4 times -8/3 squared gives me 64/9.
Wait. Wouldn't you cross it?
Not, you have to do the exponents first.
Oh.
-4 times -8/3, that's plus 32/3 minus 1. Now we can cross-reduce before we go any further on it. So 3 goes into 3 once, and 3 goes into 9 3 times. 4 goes into 4 once, and 4 goes into 64.
16 times.
16. So let's rewrite this. This is -16/3 plus 32/3. Since everything is over 3, can we rewrite -1 as something over 3?
1 over 3. No. 9 over 3.
3/3.
Oh, just kidding.
Because 3/3 reduces to 1, right?
Yes.
We want to have common denominators here so we can add all of them up. Okay, so let's combine all of these. That gives me y equals
Wait,
-16/3 plus 32/3. 16/3 minus 3/3 gives me
12. No.
13/3.
wait, that's still negative.
Yeah, because we have a negative up here.
But
The-
we're
the-
multiplying by a negative.
This became a positive when we squared it.
Oh, okay.
Where did you get 13/3?
So the vertex is -8/3, positive 13/3. That's my vertex. So let's box it so we don't lose it. Okay, so how do I graph that? We have to estimate here. -8/3 is -2 2/3.
Yeah.
So that would be -2 2/3 would be somewhere here. And then positive 13/3. 3 goes into 13 4 times. 1, 2, 3, 4. So it's somewhere right here.
How did you figure that out?
What is
So all I did to graph these things, because they're improper fractions, I just changed them to mixed numbers. So this is the same as -2 2/3 and positive 4 1/3. So I graphed that. So you can change it to a mixed number to graph. That's my vertex. So the next thing was the line of symmetry. Line of symmetry just goes straight through the vertex. So draw the dotted line. Okay, so line of symmetry is the x-coordinate or the y-coordinate? The x. So it's x equals -8/3. Okay. And then last thing we get to do is draw the parabola. Is this parabola opening up or down? How do you know? Because it's negative. So we're graphing downwards. Okay, since I'm opening downwards, do I have a max or a min? A max.
13/3.
So my max is y equals 13 over 3, yep. You just take all the information from the vertex. And that's my graph. Remember how when we've been solving, we're actually looking for x-intercepts. When we set everything equal to 0, we're actually looking for those 2 points where the graph crosses the x-axis. So let's practice that a little bit. So example 3, your instructions are just to find the x-intercepts. Not to graph, just find the x-intercepts. So if I'm looking for the x-intercepts, that means y is equal to what?
0.
To 0. So all we have to do here is plug in 0 for y. Okay, this is something that we know how to do. After I set everything equal to 0, then what do I do?
Oh, no.
We're
Set that
solving,
to
so I don't want to FOIL. That would
Set
undo
that
it.
to 0.
Yeah, set each one equal to 0. So x minus 8 equals 0. X plus 2 equals 0. Add 8 to both sides, so we get x equals 8. Subtract 2, so x equals negative 2. So my two x-intercepts are 8 and negative 2. So now you might get an equation, and your instructions are to find the x-intercepts. You are still setting the whole thing equal to 0. Okay? So it's all the same steps. You're still setting everything equal to 0. Okay?